Hello, everyone. It's Phil Jones from Projector Reviews, and joining me is Travis Scheckel from Texas Instruments. And today we're going to be talking about advancements in DLP as well as light sources to support DLP-enabled devices. So, Travis, how are you?
I'm great. Thanks for inviting me, Philip.
But before we get started, we always have to thank our sponsors, AV Pro and Meridio, for helping us put on this year's Fall Projection Summit, where we talk about all things related to projectors, whether it's projectors, screens, accessories, and all the things you need to design a great projection system. But a big part of a projector is its imager, the imager that is used to make the picture. And if you have a business projector, home theater projector, portable projector, education projector, you will notice that a large majority of them utilize DLP. So Travis, why is DLP so popular with projector manufacturers?
Well, I think it offers them a very slick solution that looks just incredible on the screen. And we've been doing this for 25 years. We continue to make improvements, as we're going to talk about today with our latest pixel design. We continue to make improvements to enhance color, to enhance brightness, to enhance contrast. And that's where we're in the business, is to make a good looking picture.
It's interesting too that DLP is utilized in more than just projectors, right? I didn't know that until I started talking to some of your team members at Texas Instruments, that there's other things that you can utilize DLP images in.
Absolutely. There's medical imagers, there's 3D scanners, printers. There's all sorts of applications that are being used more and more in consumer electronics as well.
You guys are always innovating, and because every time I turn around, there's a new solution to make DLP better. So do you have anything new for 2022 that you guys would like to talk about?
Absolutely. You know, you can't stop, right? You have to keep innovating, and that's what we're doing here. And I really wanted to talk about, again, our new pixel design that we released just over a year ago to the market. And we call this pixel, we give them nicknames, and this one's called HEP, H-E-P, and it stands for high efficiency pixel. And the whole idea behind this pixel, it's optimized for solid state illumination. So we're talking about LED, RGB laser, laser phosphor type of illumination sources. With these advancements in this pixel, we are able to support up to 5,000 lumens just with P2 LEDs. And if you take that to a laser phosphor system, we can support well at 20K lumens and above. And so we're really excited as things tend to move to brighter images, tend to move to solid state illumination. This is positioned very well for us.
If you look at ultra short throw, a lot of those projectors are utilizing DLP because of the reliability and their ability to produce really bright, vibrant images. Why don't you, like I said, recap the advantages compared to the older stuff compared to what this is offering again?
Well, what we changed in this pixel, or what we enhanced in this pixel, I can list some of those things out. So oddly enough, we actually increased the size of this pixel a little bit. Our previous generations were 5.4 micron and 7.6 micron. We actually increased the size of this pixel to 9 microns. And again, that's to tune and match some of those solid state sources, such as LED. LED, if you look at the emissions cone that it has, it's actually a pretty fairly sized area when the LED emits light from. So to take advantage of that full light, we made the pixel a little bit bigger. And another thing we did is we increased the tilt angle of the pixel so that you could more efficiently or better direct light where you wanted it to. So the tilt angle on this pixel is 14.5 degrees, where previous generations were in the 12 degree range. So we've made those advances, and because of those two things, we're we're really able to achieve about 2x the diffraction efficiency of those other 2 pixels I mentioned, the earlier ones.
The more you can adjust the angle and the more variation you have in the angle, the more you can redirect light, which means the more shades of color you can make, right? And then the
Right.
more you can redirect the light from the light source away from the lens,
Right.
the blacker the black you can make.
The colors,
So,
yeah, the contrast.
over the last few years, the contrast capabilities has gotten better and better, better blacks. And when we talk about HDR, you need more shades of colors because HDR content has a bigger box of crayons, and you need to be able to reproduce that.
Some of the technology advancements we made besides the tilt and the size of the pixel, I think are important to list out here, and they will help you understand why we're getting better efficiency as well. So we have in the middle, right in the middle of the mirror, the pixel, we have a via, and that via connects to the hinge point that mirror tilts on. And with this HEP pixel technology, we actually fill over that via and match the surface to look like the rest of the mirror. So it's one smooth, continuous plane, and that helps reduce stray reflections and that sort of thing, where you might have light going in different directions, and that reduces or eliminates that. One of the other things we did is we took the pixels and we put them closer together on this node. So basically, the gap between the pixels is less. So we call that the mirror fill factor is higher here, and that helps a lot. And then why I wanted to bring this up is because you just hit on the main point with contrast. One of the other things we do with our DLP chips is around the box of active array mirrors, we put what we call pond of mirrors on the outside of that active array. They're also pixels, but when you power that device up, those pond of mirror pixels turn off. They only turn off. And what that creates is a very black border around the picture, like you were just talking about contrast being so important, right? So not only do we have that palm of mirrors, because we've had that before, we have matched very precisely the color of the off state of those pond of mirrors in the active array, so that if you have black on the active picture side, they're going to blend very nicely. And then if you have a bright image, that black border is going to give you very high contrast. Does that make sense?
That absolutely makes sense. The other thing too, and let's talk about, is fill factor is important, because if you get closer to a screen, sometimes you start seeing the pixels, and it's almost like looking through a screen door. You can kind of see where the pixels that make up the image. So the closer fill factor means you can get closer to a larger image, and the pixel structure is not noticeable. The next thing is if you increase the resolution and you put more pixels on screen, those pixels get smaller and they're less noticeable. So what is Texas Instruments doing with DLP to increase the displayed resolution?
So with these chips, and I have a little sample here. I don't know if you can see it, but the shiny mirror in the middle there. This is actually one of our new release devices for the HEP Pixel. This one happens to be a 0.8 inch diagonal DMD, and this is WUXGA resolution. Okay. We have a similar one that's just a little smaller, 0.78, that would be a 1080p resolution. So those are the native that we can support. Now, we use our pixel shift technology to be able to shift each pixel in 4 different locations, and we can create, with those 2 native chips, we can create a 4K UHD picture, and we can also create, if we 4-way shift the WUXGA, we can support what we call, internally we're calling 4K plus, and it's essentially a 3840 by 2400 array size. And you might ask, why would you do that? Why would you have 4-way shift WUXGA? Well, if you compare, area of that type of picture to a 4K UHD image, which is only 16:9 ratio, you're actually getting about 10% more mirror area for that design, and that just means more brightness. And we're all trying to get more brightness. So those are kind of the resolutions that we're supporting at this point with those pixels.
Yeah, and the other thing about that 3840 by 2400 is a lot of times in business we talk about collaboration, multiple laptops on the same screen. So if you're trying to look at multiple spreadsheets or multiple designs, or you're or for collaboration, you can have four WXGA images on that screen at the same time, which really does help with productivity when it comes to business applications. So there's definitely some advantages to the 4K plus technology.
And I agree, and 100%. And you hit the nail on the head. Is not only in business conference rooms, but also in education. There is a lot of infrastructure out there today that have 16:10 ratio screens. And so this type of approach would basically take advantage and full use of that screen area.
Yeah, that's true. You don't have to retrofit your screen because you want to increase your resolution beyond WXGA, which with WUXGA, those things get so long, these abbreviations. Now, the other thing that's kind of interesting that I always stress when it comes to DLP, the mirrors are moving so fast that each mirror can do the job of multiple mirrors. Because one mirror could actually write 4 pixels, but it's moving so fast that you see 4 pixels from that one mirror. And people say, well, how is that possible? And I stress to people that if you look at a DLP device, a single chip DLP device, it's showing you red, then it's showing you green, then it's showing you blue, and then maybe it'll show you yellow or white. And it's moving so fast that your brain stitches together purples and magentas and cyans. So if it's moving so fast that you can't tell that imager is showing you one color at a time, you see purple, it's moving fast enough that you can't tell that mirror is writing 4 pixels. So what matters is displayed resolution. What am I seeing on screen? Not how many mirrors or number of mirrors on that imager. If they move them fast enough and efficiently enough, you see what you need to see, which is the resolution and the colors that you're looking for. And these guys are great at doing that. It's proven across a huge amount of devices. Now, there's a lot of little mirrors in that little chipset. Reliability. What about, do I have to be concerned with that?
Well, not only the chip, but the projector in general, and that's why I think a lot of projectors are moving to solid state illumination, like you talked about earlier. You're getting rid of moving parts, right? Of bulbs that can go out, right? But as far as the chip goes, again, this one that I have an example of, this is hermetic packaging, so it's very robust packaging for our DMD array, and what that means is it protects against dust, getting in there and affecting mirrors. It also has a big effect on, humidity and any type of moisture. So, with this type of package, you lend yourself to applications that can run for years, without being touched. Industrial type of applications come to mind and that sort of thing. So, hermetic packaging does a lot there.
Yeah, and I've seen a lot of projector manufacturers that are also touting that the full optical block is hermetically sealed. So when you add a sealed optical block and a hermetically sealed imager with a laser LED light source that has a life of 20, 30,000 hours, it's great when for those people who don't want a customer, whether it's consumer, doesn't want to have to worry about maintenance, or if that projector is mounted 35 feet up in the sky in a boardroom or a lecture hall, I know that I'm going to get years of maintenance-free operation, and that, of course, is always a benefit. Now, we talked about the fact that there's improvements to its to contrast and color, But do you have measurements to show that, by the way? I'm kind of curious.
Yeah, we've actually built our own projector inside TI just as a demonstration projector to show customers. So we've made some measurements lately, and we're pretty impressed. And I always joke around when we bring customers in or just have internal viewing of this projector, and I always say this is the next projector I want in my house because it is gorgeous. We're able to achieve, again, this is a LED-based projector using Osram P2, very affordable LEDs. We're able to achieve 1700 to 1800 to 1 contrast ratio. We're hitting 3000 lumens with no overlap on the LEDs, and if we do add overlap, it's easy to get to 3500. We are able, with that projector, you talk about some of the standards that are out there in the industry, right? If we look at like the Rec 709 standard, which is for HDTV, we're able to cover the full color gamut. We actually cover 107% of that color gamut with this device. And if you look at maybe a newer spec, say Rec 2020 for 4K UHD, we're able to still hit 100% of that color gamut. So we're really happy with the output here, and we look forward to seeing these in the market soon.
There's two parts of contrast too. There's native contrast, and then there's dynamic contrast. People see these huge numbers, 8 million or infinite, dynamic contrast. That's basically switching the laser light source on and off. So, but native contrast is what helps you see a person wearing a black jacket with detail in a dark room and hiding in the shadows. And when you start getting into 2,000-3,000 native contrast, it's actually very good. So a lot of times, and when you combine the good native contrast with efficient dimming of a laser light source, whether it's or a solid state light source, whether it's a laser or an LED, you end up with beautiful looking space scenes with stars and bright, vibrant football games all being effectively displayed.
You mentioned native contrast, and that's the number that I mentioned earlier, was that kind of the 1800 to 1. Some of our customers might be able in their design to achieve much higher contrast than that. So it's really, it is up to implementation, but starting with a good base, and that's why we built the kind of the demo projector, is to be able to show what we think is possible, right? And that ratio, that 1800 to 1, that's probably 2 to 3x what we've had on previous pixel designs, to be honest. So it is very sharp.
So we're talking about that you have to mate the imager with the light source, and that's what gives you color and contrast. But we also have to talk about the optics, because when you decide you want to develop a new imager, developing the optical design to go with it could be a pretty big investment. What is Texas Instruments doing to help people who are interested in utilizing these great new HEP DLPs in their particular solutions?
Great question. Yeah, we have a good third-party network that we work closely with, obviously being in this business for this long. As an example, the demo projector that I've been talking about, we have worked with a company called Sun Yang to develop that lens, and they developed it for us. We implemented it in our projector. They now have that tooling that they can sell to other potential customers. There's also third-party Young Optics, who we know has also developed their own lens and demo projector for themselves. And as a matter of fact, we're going to be, just a little heads up, we're going to be showing kind of both these in our CES booth in 2023. So I think we have a good start on available lenses. Like you said, it can be an investment to begin with, but now that the tooling has been done and is ready, this should help our customers, keep that cost down when they go to build their projectors.
Okay, so great technology. I'm excited to see it at at CES this year. When do we expect to start seeing these types of projectors equipped with this HEP technology? And when am I going to start seeing those?
They'll be rolling out soon, in 2023 for sure. And I think, some of the applications that we've seen initial interest for are high brightness applications, pro video, high-end home theater, that sort of thing. So the first implementations you'll probably see are probably going to be 3-chip DVD and DMDs, and then they'll move to some of the single chips. But yeah, expect them in 2023 for sure, and they'll be concentrating again probably on that high end, like I said, in the 20K lumens to begin with, and then we should see some of those projectors hit the market, LED based in that 3 to 5,000 lumen area, hopefully later next year.
The whole goal is just better projection, whether you're looking at a business application or a home theater or even a portable application. We review a lot of projectors a year. I would say 40, 50 projectors a year. And you can see DLP getting better and better and better. First was better imagers, then the light sources started to improve, and then you started seeing 3 LED, and even you're starting to see it's a combination, it's a package: optics, imager, light source, and as each one of those improve, the experience is getting better. The projectors can reproduce colors that you couldn't possibly imagine they could produce even a couple of years ago, and deliver resolution and sharpness and detail far beyond what was available a while back. So it's nice to see that Texas Instruments is not just sitting on their laurels, because they are the #1 supplier for imagers, for projectors, that you guys are continuing to push the envelope and encourage your partners who make the light sources and the optics to push the envelope as well, because everybody benefits from that, whether it's a business user or a consumer. So to learn more about the Texas Instruments offerings when it comes to DLP and their applications, go to ti.com, and you can explore Texas Instruments' wide range of DLP solutions and some of the other great technologies that are offered by Texas Instruments. And of course, to learn more about some of the great DLP projectors, whether it's business or consumer or portable, be sure to check out Projector Reviews. So Travis, thank you very much for coming. And hopefully everybody here has learned a lot or more about the new things coming from Texas Instruments. So Travis, thank you very much.
Thank you, Phil. I appreciate it.
All right, so take care, everyone, and we will talk to you soon.